In Unit 3, Part 1, we are solving systems of equations by graphing. So we are going to start by graphing our first equation, which is y equals negative 3x. We are going to start at our y-intercept, which is 0. So over here I'm going to plot my point at 0, and then I'm going to go down 1, 2, 3 over 1. 1, 2, 3 over 1. Once we have our line, we're going to graph our second line, which is y equals negative 4x plus 2. So we're going to start at our y-intercept, which is 2, and our slope is 4, so we're going to go down 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1. Now that we graphed both lines, we want to find the POI, which stands for point of intersection. So if I take a look, my POI is going to be right here, which is at the point x is 2, y is 1, 2, 3, 4, negative 6. So we're going to have 2 comma negative 6. So our point of intersection, or POI, is 2 comma negative 6. What we can do to check to make sure that this works out is we could plug 2 back in for x for both of our equations to make sure that our y value turns out to be negative 6. So if you plug it back in the first one, negative 3 times 2 equals negative 6, so that works out. Negative 4 times 2 is negative 8. Negative 8 plus 2 gives you negative 6. Looking at example 2, we are going to take the first equation, y equals x minus 4, and we are going to graph, starting with the y-intercept at negative 4. 1, 2, 3, 4. Our slope is 1, so we're going to go up 1 over 1, and we're going to connect our line. We're now going to graph y equals negative x plus 6. So we're going to start at positive 6. 1, 2, 3, 4, 5, 6. Our slope is negative 1, so we're going to go down 1 over 1. I always get in the good habit of plotting the points until I see where they're going to cross. So if I take a look, I'm crossing here at this point. So I'm going to draw my line. So looking at these two lines, the point of intersection is going to be 1, 2, 3, 4, looks like 5, 1. So x is 5 and y is 1. And again, we can plug that back in to make sure that they both work out. Example 3 is just like the others. We're going to start at negative 2, and our slope is 2/3, so we're going to go up 2 over 3, up 2 over 3, and we're going to make our line. The second line is going to start at 3 and go down 1 over 1. So 1, 2, 3, down 1 over 1. I apologize for my lines. I can't use a ruler on this, so they're kind of wonky. So again, I'm drawing that line and those points until I see where they're going to intersect, and I'm going to make my line. So my ordered pair for this problem is going to be 3 comma 0. So these two lines intersect at 3, 0, and I can plug 3 back in and make sure that both equations equal 0. Okay, so for problem 4, we are going to graph our line. So we're going to start at 3, and we're going to go down 2 over 1. So down 2 over 1, down 2 over 1, and again I'm going to continue and I'm going to draw my line. I'm going to graph my other equation, which starts at 4 and also goes down 2 over 1. So I'm going to go down 2 over 1, down 2 over 1, oops, and I'm going to graph this line. Now, since I don't have access to a ruler with this program, it's very difficult to draw a straight line. So you should notice that these lines are parallel. So what happens with parallel lines, our POI, we don't have one, so we would write no solution. So nothing would ever work because these lines would never, ever, ever intersect. And one thing I want to point out is that the slope is exactly the same. So if you have the same slope, your lines are going to be parallel and they will never, ever intersect. So there is no solution. For the last example, we are going to graph y equals x plus 1. So we have that graphed, and then we want to take a look at the other equation And you will notice that this is not set up in y equals format, so we're going to do that. So we'll divide everything by 2, which will give us y equals 1x plus 1. Well, if you take a look at the new equation, it is the same as the first equation. So when that happens, when they are identical, you don't have to draw 2 lines because they're exactly the same, but our POI would be all solutions or many solutions. Any number would work because they're exactly the same line. So you can write many solutions or all solutions. So we are going to take a look at the substitution method tomorrow, but this is just kind of an idea of how to graph and to find your solution.